Hey there, welcome to the intro video where we're looking at two-dimensional measurements. And you should have a formula sheet for this unit. This is the formula sheet that you guys are actually going to have access to on the SOL. And when we're talking about the two-dimensional stuff, it's the stuff that I have highlighted here. We're going to be looking at the two-dimensional polygons and then circles as well. And then later on, we're going to be exploring the 3D shapes. So we're not going to worry about this 3D stuff for now. At the beginning of the video, I actually want to go ahead and call your attention to one of the things on the formula sheet that we've already covered, which is right here, and it's the Pythagorean theorem. And we have the Pythagorean theorem to find the missing side of any right triangle. I could give you the hypotenuse and ask for you to find one of the missing legs. I could also give you both of these legs and ask for you to find the missing hypotenuse. All right. So for this video, what we're going to be actually doing is just exploring these formulas that you probably already learned in elementary school. So we're just going to review some of the ins and outs and just kind of start very easily reviewing those formulas. And then later on in the unit, we're going to kick it up a notch with some kind of tougher shapes and things that look like this. But for today, we're just going to take it nice and easy and review all the formulas from 6th grade that hopefully look familiar from this formula sheet. All right. Now on this page in your packet, we actually have, it looks like 1, 2, 3, 4, 5, 6, 7, 8 shapes that we're going to review how to find the area and then the perimeter or the circumference of, okay? Now when we talk about area you guys know is the amount of space inside these 2D shapes. And then perimeter is the distance around a polygon. Circumference is the word we use for the distance around a circle, all right? So that's all we're focusing on today is filling up the inside or the distance around each of these shapes. Now on your formula sheet, we have all these different formulas, and I'm just going to keep them listed off to the side right here just so I don't have to keep flipping back and forth. These are the formulas that we would care about from that formula sheet, all right? Another thing I'm going to be doing in this video is actually reviewing Desmos with you guys and how if you can just type in the formula and then you know how to read the shapes with the dimensions, you will be able to use Desmos to calculate the area, perimeter, and or circumference, all right? So with that being said, we're going to go ahead and get started here with this first shape. It's a rectangle. Very, very, very easy. I think that you guys are comfortable with the fact that for a rectangle, we're going to use the base times height or length times width. It doesn't matter which one you want to use. It's the base times the height, or if you want to think of it as length times width. And then for the distance all around it, we're going to use this one. It's just twice the length right here and here, and we're going to add that to twice the width. All right. Now for area, obviously 8 times 3, the area is going to be 24 square centimeters. So you can go ahead and jot that down. And for the distance around it, I'm going to basically take 2 of the lengths. So 2 times 8, that's going to be a 16. And then 2 of the widths. So the 3 plus the 3 here is 6. And here we're going to get 22. So the perimeter would be 22 centimeters. Okay. So I got a 22 for my perimeter and a 24 square centimeters for the area. Now, when we're looking at this parallelogram here, a lot of times you're just going to see the base times height for that, and it's the base here is a 6. Now, we got to be careful between the 5 and the 4. What is the true height? And I'm going to do you guys a quick favor. I'm actually just going to kind of sort of sketch and trace this triangle right here. If I move this over, that's basically a rectangle right here. It's taking up the same area as this black rectangle. So that's why we can just say it's base times height. That's why we get to use that formula. And if we look at the base of this thing, it's a 6. And the height is this 4. So we've got a 6 by 4, so 24 square inches. Okay, that's the area. And for the distance around it, we're just going to add up all the sides. I've got this 6 and this 6. All right, so that's 12. And then I'm just going to add 10. And that's also going to be a 22, which happens to just be a coincidence that it's the same answer as the first one. All right, so that takes care of our rectangles and parallelograms. For rectangles and parallelograms, here's how you find the area, and here's how you find the perimeter. Okay? All right, sweet. Now let's focus on these shapes here, which are called trapezoids. And if you need to write that down, if you want to spell that, it's just the word trapezoid. And I think between the two trapezoids that you see here on your notes, between these two trapezoids, this one over here to the right is kind of the more familiar looking trapezoid. This one, the first one that I have, this one's actually called a right trapezoid because it has right angles. So there's two types of trapezoids out there. We have the right trapezoid, because again, you see the right angles. And then this one, where this side and this side are the same, kind of like in a triangle, it's called the isosceles trapezoid. Isosceles trapezoid. So there's just two types of trapezoids. And like I said, I think you guys are more familiar with this one. But we're going to start here with finding the area of this right trapezoid. Now on your formula sheet, when you look at the trapezoid, it has here the area, that's the formula. And I already have it typed here for y'all just because this one's, I think, the newer one for a lot of students. And not everybody understands how to use the trapezoid formula. So I'm going to break this one down for you guys. The height, I just want to be very careful here with the height. The height is actually the amount of space between the bases. Now B1 and B2 are the parallel sides, okay? So they're called the bases, and you can identify them as the parallel sides. It's not always going to be the bottom, which is what a lot of us think when we think of the word base. But so the bases, B1 and B2, are the parallel sides, which means the height is that space between them. So when we're trying to find area of a trapezoid, it's going to be half the height, and I'm going to color code this for y'all, so half of the 2. And then you're going to add the length here of B1 plus B2, so 5 plus 3. That's how you take this shape and read the dimensions to plug it into this formula. The 2.8, we do not need to find the area, but the 2.8 we will need in a second when we need the distance all around it. Now for this, 5 plus 3 is 8, and then I could just use PEMDAS, like half of 2 is just 1, and 1 times 8 is 8. So we've got the area here would be 8 square meters. Now real quick, what I want to do is I actually want to pop over to Desmos, and I want to remind you guys that you can use Desmos right here. The only thing that stinks is that, like with Desmos, it's kind of hard to tell it like a B1 and a B2. So Desmos really is kind of tricky with this one. You could say, okay, I'm going to do like a 1/2. Let me type in the 1/2 here. Oops. You could say 1/2, and then you've got the letter H. And then you could say parentheses, and you could use the letter B for the first base, but then maybe just use like an X for the second base. And then say, okay, the height was that thing in red, which was the 2. All right. We said that the first base was a 5. And the other base, like I said, you can't really use B1 and B2 in Desmos. So the other base, I just called it X for this. And here it was the 3 that we saw. And you can see here, if you plug in the 2, the 5, and the 3, which is the 2, the 5, and the 3 into the formula, here it gave us the area of 8. So yes, Desmos does work for this. And I'm actually going to keep the formula in here. I'm going to keep the formula in here because I want us to be able to use it again for the next one. So I'm going to delete out the dimensions because we're going to come through and find the area using Desmos of the next shape right here. So for this one, I already have the formula again for you guys, and we just need to know what the height and the 2 bases are. So the height is not the 3.2. The height is actually the dotted line here from in between the 2 bases. So that's going to be a 3. And remember, the bases are the parallel sides. So I've got the 6 and the 4. So 6 plus 4. Now you don't need Desmos. Again, you don't need Desmos. You can say, okay, this is a 10. And half of 3 is 1.5. So 1.5 times 10 would be a 15. So you don't really need Desmos because the math is kind of easier math. But to just point it out to you, again, if you have the height here, we said the height was a 3. The first base was a 6. And the other length was a 4. So again, we can see the answers agree. That's 15 square centimeters for the area. So we've got the area figured out for the trapezoids, and I mean perimeter, y'all. Perimeter is super easy. I just wanted to just like remind you of what it was. It's just you adding up all sides. So for this one, if I do the 5 plus the 2 plus the 3 plus the 2.8, if I just add them all up, the perimeter here is going to be a 12.8 meters. And over here, if I add, I got the 6 plus the 4, we know that that's 10. And then I've got the purple sides. This purple side is 3.2, and this is a 3.2. So 3.2, 3.2, that's a 6.4, plus my 10. So the perimeter here would be 16.4. Just adding up my sides. All right. So those are some quadrilaterals. Those are the things with 4 sides, and that takes care of, again, this formula and this formula on the formula sheet. And then of course, because it was just a newer one, I went ahead and typed it in the notes for y'all here. All right, so now let's take a look at reviewing again the formulas for circles and then for triangles. Now for circles here, to find area, when you're looking at your formula sheet, area is going to be the pi r squared. Pi, we're going to use 3.14 for pi. The radius in this situation is a 4. And I wanted to review that if you're not going to use Desmos, you care about doing 4 squared first. This is going to be a 16. And then that 16 times 3.14 is where I'm going to get a 50.24. If we don't use Desmos, if we use a regular calculator, I'm going to show you guys a really common mistake here. Oftentimes people will type in a 3.14 and then they'll do times 4 and hit squared. And so what we want to do here, just be careful, you want to do 4 squared. That happens first. Now we want to do times 3.14. Sometimes the mistake is people get the 3.14 times 4 and get that answer, and then they square that thing. Nah, that's not the right thing to do. All right, but this is a 50.24, and this is going to be square inches. That's the area. Now for the area of the one next to it, it's the same formula, but this is what I wanted to review in the video. That sometimes the picture over here draws the line halfway through, which is the radius. Now the picture over here draws the line all the way across, so it's a diameter of 21, which means the radius, we do need to take the time to cut that in half, and we care about the fact that this is a 10.5. So just be careful about how to read the shape. And so now we're just going to do 3.14 over here. The radius, we're going to use the 10.5, and that's what's getting squared. We don't need the 21, we need the 10.5. So I'm going to do 10.5 squared. Cool, I got that answer. Now I'm ready to do times 3.14. And here I'm actually going to use this 5 to bump this up. We'll do 346.19. We'll do 346.19. And that's going to be square miles. Sure, you can use Desmos. You sure can. On Desmos, let me just clear out here. I'm just going to clear out the trapezoid formula. And now I'm going to come through and say, okay, so it's 3.14. I'm going to use 3.14 and then type in r squared. Now for the first one, remember the first one was just the radius was a 4. So boom, there's the area. And remember, you can keep Desmos in there and say, okay, for the next one, the radius was the 10.5. And there again, it's just using that formula. It changed up the radius, so it got a new answer for area, and we just rounded it. Now for circumference, you've got one of 2 options on your formula sheet. It has 2 options because sometimes, like here, the picture would give you the radius, and sometimes the picture gives you the diameter. So if the picture gives you the radius, cool, you can use that one. And if the picture gives you the diameter, cool, we can use this one. It really doesn't matter because 2 times the radius is the diameter anyways. So 2 times the 4 is going to be an 8. So then 8 pi is my answer here. So 8 times 3.14, 8 pi. Okay, so 25.12 is the distance around. And for this one, 3.14 times 21. All right, so 3.14 times 21, 65.94. Now for the distance around, when we label it, that would just be the miles here. Square miles is area inside. So here we can put inches. All right, so we just reviewed how to read the circular shapes. Sometimes there's a radius, sometimes there's a diameter, and the different formulas involved. So we've taken care of this formula now, this formula now, and this formula now. These were already done. So the last one now is for triangles, where the area is half base times height. All right. So we have a right triangle here, and the base of this is the 1. The height is the 5. We don't need the hypotenuse here. So for the area, it's the 1/2 base times height, so half of 1 times 5. Well, 5, half of that is a 2.5, so 2.5 square meters for the area. Now the distance around it, we simply just add up the 3 sides. So I got 1 plus 5 is 6, and then 6 plus 5.2 would be 11.2. That's my distance around the perimeter. And I can label that actually with meters, 11.2 meters. Cool. And now for this, it looks like an obtuse triangle. So for the obtuse triangle, it looks like here the base is this 13.7, and the height is listed out here, the 3. So for this one, area is half base times height, so half the 13.7. The height's a 3. I might bust out the calculator for this one. I know half of 3 is 1.5, so I'm just going to use the 1.5, and then times 13.7. Cool, 20.55. So that's the area, 20.55 square centimeters. And even though it looks like centimeters squared, we say square centimeters. And again, for perimeter, we just add up the 9 plus 6, which is 15. And now I've got 15 plus 13.7. So 28.7 centimeters. The distance around is 28.7 centimeters. So the purpose of the first page here was simply to review the basics of the formula sheet. Here we just covered area of a triangle. We talked about how for the parallelogram and the rectangle and square type shapes here, we've got base times height, or again, length times width, same thing. We talked about the distance around them, twice the length and then twice the height. We've covered that for these shapes here and here and here. We covered the circle. We covered 2 pi r, which is the same thing as pi times diameter. And then we covered pi r squared, so we're good here. And this one, like I said, this one might be the newer kind of weird one for some of y'all. And it's easy to just spot, like you've got your parallel sides, you add them up, and you multiply by half of the height. And that's the area of a trapezoid. And that concludes this video. Thank you for watching.